Okay, so the first calculation is Q equals MC delta T. And your M is going to come from the total volume of your water. So let's say that you had, let's just say 190. Let's say that's what you measured out. C is still 4.184 joules per gram degree Celsius. And then our change in temperature, we should have ended on 4. So this group ended on 4. And we began at 60.5 for this team's data. And then you will simply calculate that. Okay, so this is where we ended, and we calculated our energy, and it was negative from the change of temperature. It was because it began at 60.5 and ended at 4.0. We had 190 total volume. We had used 100 at the beginning. That's what we heated up. So we are left with 90 milliliters, which equals 90 grams. And that represents the ice that I put in there. So what I'm going to do now is I'm going to take this number and I simply divide by 90 grams. And this is going to give me my heat of fusion for ice. Okay, so we're going to take the 499.06 joules per gram. That's my heat of fusion. It represents when ice is going from one state to the other, or when water is going from water to ice. So it's our shift between solids and liquids. To convert this, I know that my conversion for joules to kilojoules is 1,000 joules for 1 kilojoule. Then I need to go from grams to moles. My formula for water is H2O. The AMU of oxygen is 16. And then I have 2 waters, which are 1.01. This ends up being 18.02 grams per mole is actually the proper label. And so in my equation, since I have grams on bottom, I put grams on top, mole on bottom, and then I solve. Okay, so upon solving for this problem, we get 8.99 kilojoules per mole. This is called the molar heat of fusion for ice. Okay, the heat of fusion that we got from question number 2, I'm going to use to do question number 4. So I take the accepted value, which is 334.